Okay, so what we're going to do is we're going to take a look at this sum now, okay?
Okay.
All right, so one of the things that's difficult about this sum is it looks totally intractable.
Yes.
Right, this looks really complicated, but we have to remember that it's pretty straightforward. It's just the width of the rectangles and the heights of the rectangles. And what we're going to do this sum that looks intractable is we're going to have to remember just a little bit of arithmetic that we talked about yesterday. That we know what the sum from I equals 1 to n of I squared is. And what's that?
N times n plus, or I times I plus 1 times 2I plus 1 over 6.
No.
Or n times n plus 1 times 2n plus 1 over 6.
N times n plus 1 times 2n plus 1 over 6. And the sum I equals 1 to n of I. We know what that is.
N times n plus 1 over 2.
N times n plus 1 over 2. And then the sum from I equals 1 to n of 1. What happens when I sum this?
Just n.
I get n. Okay? And that means I actually know a little bit about how to sum this term, how to sum this term, and how to sum this term separately from each other. Do you understand what I'm saying, or no?
Not really.
Okay. This sum looks very difficult because it's a product of 3 different things.
Yes.
So what I'm going to do is I'm going to make it 3 different sums. I'm going to say this is equal to the sum from I equals 1 to n of, do you know what 6 times 36 is?
It's 216.
216 over n cubed times I squared. And now remember, this part doesn't change at all in any of the sums, so I can actually even bring that outside, and then when I bring that outside, I just have sum of I squared on the inside.
Yes.
And I know what that is.
It's n times n plus 1 times 2n plus 1 over 6.
Yeah. Now for this one, when I do 6 times 12, I get
72.
So then I get 72 over n squared times the sum of I. And then here I get 18 over n times the sum I equals 1 to n of 1.
Okay.
So one of the things that we did to simplify what seemed like an intractably difficult sum is I just broke it into 3 pieces, and it turned out we knew how to do each one of the 3 pieces separately.
Okay.
Do you see that?
Yes.
Okay. So when I do this sum, I get 216 over n cubed times n plus 1, 2n plus 1 over 6. And maybe I'll just divide out that 6. 216 divided by 6 is
36.
36. And maybe I can even divide out the n.
Okay.
And then this one I get 72 over n squared times n plus 1 over 2. So when I simplify that,
It's 36 times n plus 1 over n.
yeah, so I get 36. And on this one I get 18 times n over n.
18.
18. So now I have an expression. 36 times n, what do I want to write here? N plus 1, n plus 1 to n plus 1 over n squared. Plus 36 n plus 1 over n plus 18. And that's when I have n rectangles.
Okay.
So what do I want to do now?
Go to infinity. Get your closest approximation possible.
Alright, so what does this become? What does this one become as n goes to infinity?
Just 2.
Yeah, so that term becomes 72.
That'll become 36 for the next term, looks like.
Plus 36.
Plus 18.
18. So that's 108. 18.
26.
126. So there's the area under the curve. What do you think about that calculation? Give me the pen cap.
It was a little complex, but it did break down eventually.
Yeah, it is. It seems like it's going to be a very difficult problem. And then it turns out that we can use these sum formulas that we know. And in fact, it turns out we get a very straightforward answer. Are you surprised?
A little bit, yeah.
A little? Okay. All right, well, we'll leave it there. That's the little introduction to calculus with parabolas. Good job, hun.